Hello, Canada. Good evening, everyone. Welcome to the second Astronomy North NowCast, Astronomy North live event, coming to you from Whitehorse in the Yukon. I'm James Pugsley. I'm with the Astronomy North Society, and we're offering this week something new, something exciting, live events on YouTube, and I think in part because the sun has forced us to step up our game. There's lots of activity going on in the sun over the past week, and that means that there is a possibility of significant activity, geomagnetic activity, on Earth. Some of the events were Earth-directed, and as a result, it's going to mean potentially nice auroras above northern Canada, possibly more activity above southern Canada than usual, if in fact the storms live up to the expectations. So last night, just as a quick recap, the storms did not live up to expectations. That's primarily because one of the gusts of solar wind that was due to arrive in the evening, or I should say in the evening local time on the west coast, which would have been a little bit later, obviously, on the east coast, it arrived really early. It arrived in the middle of the day for Canada. So that meant auroras were visible above Scandinavia. It wasn't even dark in Canada yet. So we waited and we waited and we waited, as per normal. Whenever there's a geomagnetic storm, you just don't know exactly when the auroras may come out. However, what we observed last night was that the number of strikes against Earth's magnetic field were not as predicted. I think the original thought was there may be 2 or 3 of these coronal mass ejections, or these winds, these gusts of solar wind that might impact Earth's magnetic field. It didn't happen, or if it did not have a significant enough effect or impact to trigger active northern lights last night. That being said, there was another phenomenon that occurred last night, and that was that the Earth's magnetic field and the magnetic field of the solar wind, which comes with its own magnetic forces and its own magnetic baggage, they didn't work well together. A lot like a bar magnet, when you put a north and a north together, you get resistance. That happened for quite an extended period last night. So what we're hoping for is that tonight, if we have some incoming solar wind and a couple of solar wind gusts that are actually, if we do get them, they're going to be indications of either a really late arrival from yesterday or an early arrival from tomorrow, because the prediction is there won't be a significant impact tonight. However, simply because there's so much going on in the Sun-Earth system, it's still good to post our next live event on YouTube. So that's why we're doing it. It's still possible that there will be G1 to G2 storm still possible to have a G1 or G2 storm this evening, overnight. And for that reason, we're going to leave this channel open, and we welcome you to visit throughout the night. And if you're interested in space weather, we'll be talking a bit about some of the data, about some of the real-time imaging that we're seeing from across Canada, thanks to Themis Canada, as well as this incredible camera from Churchill, Manitoba, and other cameras that may be coming online tonight. So we'll be checking things out as it happens, and I'll be popping in and out with some commentary. If we can see some activity, I'll do my best to just jump right in, and we'll do the play-by-play. But I just want to encourage everybody, be ready tonight. There could still be some activity, and it may surprise you, because that's what the aurora is all about. That's what the magnetic field's all about. It's full of surprises. So anyway, stay tuned. Enjoy the show. The sun is still up in eastern Canada, but it's starting to go down. It's 5 o'clock in Yukon, 8 p.m. in Toronto, Montreal, Ottawa. So get ready for nightfall. We'll watch for auroras above the northeastern horizon. If you live in northern Ontario, northern Quebec, Newfoundland, and Labrador, you're going to want to look east, northeast, right after sunset. See if you can see some activity. If you live in Nunavut, again, you're looking east tonight, right after sunset. See if you can pick up an early auroral arc. And that's the start of the evening. East Coasters, get ready. You may see some auroras tonight. Enjoy the show. I'll be back. My next update will be at 6 p.m. local time in Whitehorse, 9 p.m. Eastern. Okay, we'll see you shortly. And for more information about tonight's forecast, I recommend going to astronomynorth.com because why not? It's going to be a great night. Thanks for joining us. We'll see you in a bit. Hey YouTubers, hey Skywatchers, and we're back. It's 6 o'clock local time in Whitehorse, 9 o'clock Eastern, and we're keeping an eye on the sky for possible auroras this evening. If you're just joining us, this is the second ever Astronomy North Nowcast, and we're focusing on the Geomagnetic storm watch that's been in effect for the past few days, and this is the result of some coronal mass ejections, which is it's solar wind gusts that were launched from the sun a few days ago, and they were launched in succession, a number of different blasts that just happened to be Earth directed. And the National Oceanic and Atmospheric Administration had issued a G3 strong G3 geomagnetic storm watch for last night. And so that got us thinking, well, we better do this. We better make this happen for YouTubers across Canada and the northern United States, because last night's show could have been spectacular if, in fact, we had had a direct hit and the solar wind speeds were elevated and the plasma was, had a lot of protons in it, and the magnetic fields lined up beautifully between the Earth's magnetic field and the incoming solar wind. That's what we were hoping for. And guess what? It didn't happen. It didn't happen as planned anyway. So the prediction was that we would see some initial impacts early in the evening, mountain time yesterday. And it didn't happen. It actually happened much earlier than that. So it was still the afternoon, early afternoon in the Northwest Territories when that impact occurred. And so that meant for Toronto, for Ottawa, for Montreal, Halifax, it was still daylight. And therefore, we did not have any auroras visible above Canada at that time because it was still day. And the auroras were spotted, of course, above Scandinavia. And that's when we saw that there was a brightening of the auroras around what would best be described as afternoon in Canada, but they were above Scandinavia. So that being said, that wasn't supposed to be the end of the show. It was supposed to be this kind of the start of the show for last night. What ended up happening? Well, the rest of the evening was relatively quiet. The space weather conditions between the sun and the Earth were still turbulent. There was still incoming solar wind with a high velocity and density. However, the magnetic field of that incoming solar wind did not work well with Earth's magnetic field. Kind of like two bar magnets where you have two north ends of a bar magnet repelling one another. That happened for a few hours last night. And that's the beauty and mystery of the Northern Lights and the geomagnetic field around Earth. It's unpredictable. That part of this whole journey of understanding auroras and understanding the sun-Earth relationship, that's the part that is arguably the most unpredictable. So space weather forecasters look at what's happening on the sun. They look at the relationship, or sorry, the space between the sun and the Earth, and they try and estimate when the solar wind gusts will arrive at Earth. That part, not we, but they at NOAA and Space Weather Prediction Center have done a very good job to develop the tools that not only identify the speed and the direction of the solar wind, but also help the public understand the speed and direction of the solar wind. Now, that being said, they get it wrong. They get it wrong for reasons that we kind of take for granted, and that would be you cannot predict what the magnetic polarity is of that incoming solar wind. You wouldn't know it until it arrived at Earth, and that's what happened last night. It arrived, and it didn't produce a major event, so we did not have intense auroras, active auroras across Canada and the northern United States. I did observe a couple of things, though. Maybe I'll put this out there. We had a couple of messages that were identifying that it was a 90% chance of severe storms at high latitudes. And I'm a bit of a space nerd on this stuff, but 90%? I mean, that's basically 100%. You better that's a guarantee. You're almost guaranteeing it. And that's a big no-no in the aurora in the aurora world, in the aurora science community. You really don't want to talk about guarantees. You don't want to talk about certainty. You want to talk about probability. So yeah, there was a probability, according to a couple of websites, that there was going to be a 90% chance of extreme or really, really severe turbulence and therefore geomagnetic activity, therefore auroras at high latitudes, and that didn't happen. So does that mean we were the lucky 10% last night? I don't know. I don't want to be critical. I'm just saying we don't see 90% very often. And last night, with that incoming solar wind, there was something important to note, that there wasn't certainty that that incoming solar wind was definitely going to impact the Earth. There was certainty that there was a probability that it would impact the Earth, but there was not certainty that it would certainly impact the Earth. I don't know why I'm going off on this tangent, but anyway, every now and again, when we see the predictions, we see that their predictions are that there could be a glancing blow as this cloud of particles sweeps past the Earth. And I think that was what they were intending to say last night, that there could be up to a G3 strong geomagnetic storm. That was, I think, a fair prediction. And I think that gives the media and gives the public a heads up that, hey, it's possible. But what ends up happening whenever we have a slow news cycle, or we have, haven't had a lot of geomagnetic activity in a while, is we latch on to the G3 that it's definitely going to happen. And as we can see, it doesn't always happen. It's more a question of it could have happened. Had there been direct impacts, had it become the perfect conditions for the magnetic field and the magnetic structures that are coming towards us, yeah, we would have had some pretty glorious auroras last night and pretty impressive data from yesterday. But we see that, of course, that didn't happen. But that doesn't mean that it couldn't happen after the fact. And that was the other reason we stayed up late last night doing our first NowCast. That was last night. And the reason for staying up was because, generally speaking, when a gust of solar wind is arriving at Earth, they give a time, and you can see it in the top right-hand corner of the screen. It's the CME arrival time predictions using a model called the WSA-NLIL Solar Wind Prediction Model. And you can see it as these two pinwheels in the top right-hand corner. And maybe what I'll do is I'll enlarge that one item so you can see that in greater. Sorry, I'm just zooming. I'm doing four things here. I'm going to try and do one thing at a time. Let me just increase the size of the prediction model. We can take a look at that together. I mean, you'd think I could do a couple of things at the same time. All right, there we go. I got it. I figured it out. Okay. This is all new to me. This is new software. This is a new experience. Oh, by the way, I'm James Pugsley. I should introduce myself. I'm James Pugsley. I'm with Astronomy North. We're a nonprofit society based out of the Northwest Territories in Northern Canada. Welcome to the NowCast, the Astronomy North NowCast. And tonight we're featuring some pretty cool stuff. We're going to be talking about what's going to be happening based on the data. We're going to be looking at some live feeds as they happen. We'll be able to see if there are auroras visible. We'll be able to see if there are auroras visible above a number of communities across the north. And and then I'll be providing updates every hour on the hour just to say hey and see if everybody's still out there. And it's an opportunity to talk about what we see, and maybe just maybe it will be a way to help you enjoy the lights tonight and see the show. That's what we're hoping, is that I can be helpful to get you outside if they're visible above your community. Okay, so just increase the solar wind prediction model. Now I am fading in. There we go. The new guy figured it out. Okay. So what is the WSA Enlil solar wind prediction model? Let's just do a quick recap of what this chart is telling us. So this is produced by NOAA, the National Oceanic and Atmospheric Administration, and the Space Weather Prediction Center is an area of NOAA that is dedicated to understanding what is going on between the sun and the Earth. So when we look at this chart, or when we look at this pretty cool tool, we have to try and figure out, well, what is it trying to tell us, and what's going on? So when we see the yellow line moving left to right across that chart on the right, that is the date. That's just marking time. And so on the left, as it starts there, you can see it goes through the 17th, 18th, 19th, 20th, etc. So that's showing us the relative time from a window of basically the start of the 16th through to the 23rd of August. On the left are the pinwheels. The pinwheels that's just the name that they've earned because they do look like pinwheels. And they're showing us a very cool view of our own solar system as seen from above. So at the center, let's look at the top pinwheel first on the left. At the center is a dot that represents the sun. If you look to the right of that dot, basically where those waves are launching out, you can see three smaller dots. And those three smaller dots two of them are satellites, and one of them is planet Earth. I don't know if you can see the color right now live on YouTube or not, but one of the dots is purple, one is red, and the other one is green. The green is Earth. The one in the middle is Earth. And it's plotted on the chart on the right as the top on the top line. The other two satellites, or the two satellites, are called Stereo A and Stereo B, and they're in an orbit around the sun. And they're in basically a similar orbit to Earth. And the purpose of that is that there comes a point in their orbit where they actually have one satellite. One of the stereo satellites will be on one side of the sun. The other satellite will be on the other side of the sun. And then the Earth will make up the perfect triangle. It doesn't happen all the time. It's just once we get there in the orbits that we can actually look at the sun in a 3D model and understanding the data from a three-dimensional perspective. Like never before, it allows us to see all sides of the star. So it's a great, the stereo team has done amazing work to give us that kind of unprecedented look at our star. Anyway, how does it help us tonight? Well, the way it helps us tonight is we use these satellites, including the Earth, to detect the arrival of the coronal mass ejection from the sun. What is a coronal mass ejection? It's an eruption. So if there's a solar flare event or a filament that just whips across the surface of the sun, it will launch out plasma if it has a coronal mass ejection that comes with it. There's no guarantee you get an eruption of plasma on every single solar flare. But you do have the chance that that short-circuiting event on the sun, a solar flare event, can also include the release of energized particles and plasma, which is basically a chunk of the sun, charged particles from the sun. And they will launch out in all directions, and every now and again, an eruption will occur that is Earth-directed. So when we look at the pinwheel, what are we seeing? Well, we're seeing the sun at the middle, and it's rotating on its axis. And there are emissions of particles in all directions, and you can sort of see the different colors on the top pinwheel in particular. And what does that represent? Well, the top pinwheel and the top graph represent the density of the particles. So that's basically how thick is that solar wind coming out of the sun. And you can see there's some areas that are lighter blue and then darker blue. The darker blue represents that it is not a very it's not a very dense solar wind, meaning not a lot of proton density in that solar wind. And you can see that a majority of the region around the sun, therefore the majority of the area, the release out into the solar system, is relatively quiet right now. Density, it's not a very concentrated solar wind, except in one direction, towards Earth, just by chance. Every now and again, you have an active region on the sun that is Earth directed, and it launches particles in our general direction. And that's what's happened. And you can see it didn't just happen once, it happened multiple times. Some of these coronal mass ejections, that's what they're called, with these gusts of solar wind, are moving really fast. And some are moving a little bit slower. And so I think we had 3 or 4 that pop, 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 pop earlier this week. And then we had another one, I believe it was last night, our time, last night in relative to the observer, which would be in Canada. Anyway, that I won't labor that point. The point being is we had another coronal mass ejection. You can see it there. It's faster moving than the first round of CMEs, and it's due to arrive late on the 19th. So how do we know that? Well, let's look at the chart on the right. We can see, maybe I'll just stop the screen so we can just double check exactly where we're at. There we go. All right, so I just stopped the movie. Maybe I'll take it back to the moment at which we're expecting impact. So the original vision was, the original impact was to be early on the 18th universal time, which was late afternoon. It ended up being early afternoon local time in central Canada yesterday. We fast forward to the next potential impact that's predicted by NOAA, and it's calling for an impact relatively late on the 19th universal time. So for those of you who aren't sort of thinking about universal time, there is a time difference between universal time and Canada. And that time difference basically is we're about 7 hours behind in Yukon, 6 hours in Yellowknife, Northwest Territories. And if you work backwards from there, so Toronto, you are in the neighborhood of a few hours behind universal time. And what does that really mean? Well, it just means wherever you are, you want to identify what is the anticipated arrival time at Earth based on universal time, and then go online and do the calculator, do the check as to what does that mean for your time zone. And that's how we predict our arrival time for wherever you may be. So for us in the Western Canada, this is not a great arrival time, because it means likely that this is going to be an event. If there's an impact and a major aurora, it's going to be happening on the other side of the planet. It'll still be daytime here tomorrow when the impact occurs. But this is where it gets interesting. The arrival times aren't always right, and it could lead to an early arrival. The coronal mass ejection could arrive much sooner than it previously thought. And for that reason, we thought, you know what, let's just do another NowCast tonight. We'll probably do another one tomorrow night just to follow up. And so tonight we're watching to see if there are any residual impacts from last night's show. And there was a geomagnetic storm, a G2 geomagnetic storm yesterday. There were a couple of G1 events earlier today. But by and large, we haven't had a major show. I'm going to take us to the home page here so we can just take a quick peek at how things are going on the Space Weather Prediction Center website. If you've never been on the Space Weather Prediction Center website, you definitely have to check it out. It's swpc.noaa.gov. That's swpc.noaa.gov. And so this is what I was talking about. So we had yesterday, late in the day on, actually it ended up being late on the 17th universal time, we saw G2, which is a moderate geomagnetic storm. And for Canadians, that was during the day. What we're looking for is to see if we can have a storm erupt where those green bars occur. You can see right after August 18th, the first two green bars on this KP, this is the KP index. It's not a real-time indicator. It's just tracking the last 3 hours. Each of those bars represents a 3-hour window, and it is telling us did the auroral activity cross a certain threshold for a long duration, a long period of time. And I believe it has to cross a threshold of significant turbulence with magnetic field lines pushing south above southern Canada for over 15 minutes in order to be declared a geomagnetic storm. And then if it pushes further south, it'll go from being a KP5 or a G1 geomagnetic storm to a G2. And so if it has to cross that threshold and stay there for long enough for NOAA to declare that that was indeed a geomagnetic storm, or I guess for the international community that measures these things to declare it a storm. So that's what happened. We had 2 consecutive 3-hour periods where there were G2 storms that occurred. And then it went back to being relatively quiet. So the green bars on August 18th, I don't know if you can see the dates there, but you see how you have 2 red followed by 4 green. Those 4 green, that's where they predicted that there was going to be significant geomagnetic activity. Therefore, active auroras. And it would have been a nice show last night for Canada had those green bars been bright red bars today. And we look back and we say, holy smokes, look at that. We had the peak of the activity, just the right time for Canada. But it didn't happen. Instead, if we look further along to red, red, yellow, red, and that's indicating late on the 18th today, universal time, we had more geomagnetic storms. We've had a couple of G1 events, and then the yellow indicates KP4, which is an unsettled, means the magnetic field was unsettled, and then it's elevated back to a G1. So that's good news for northerners. Not as good for southern Canada. I'm sorry if you're from southern Canada listening in right now. Thank you for listening. This is not what we're hoping for you tonight. We're hoping we can actually get a higher than a G1 and potentially G2 activity for a little while, and that will mean possible auroras for northern Ontario, for Quebec, for northern Quebec, I should say. And considering what time it is right now, it's 9:30. So it's perfect time. If we had a significant geomagnetic storm right now, it's the perfect time for Ontario and for Quebec and for Newfoundland, Labrador. And you would have beautiful auroras coming in from the northeast, and you would see potentially them coming overhead if you live in rural Quebec or rural Ontario, northern Ontario. You're getting a nice show. That's what we're hoping for. G1, though, which is still a really nice display, potentially a nice display. To see a G1 event from Ontario, chances are you're looking straight north, and it'll be on the horizon. A G2 means that it'd be pushing further south, so you'd actually be able to see it potentially overhead. And anyway, that's that. So we've had a good day of storming, let's put it that way, but it hasn't been the big show, I think, that scientists and the forecasters were predicting. We'll just take a quick peek at the current auroral oval. And for those who don't know what this is a tool that is the 30-minute aurora forecast is what it's called, the Ovation Aurora Model. And when we look at it, a lot of folks use this to sort of say, hey, the aurora is now out. But I want to sort of suggest that that's not what this is telling us. It's not saying that the aurora is visible. It's saying that there's a probability of aurora in that oval. And the color, as we see in the legend there, the color scheme is important. So as activity intensifies this evening, use your words, James. As activity intensifies this evening, we're watching to see if we have darker regions on this oval, reds, oranges, like some really darker, more profound colors, because that's indicating increased probability of aurora. And this is a model that generates a video, and I'll show the video here quickly, because this video is helpful to look at the past 24 hours. So it's called the 30-minute aurora forecast, but it's actually doing something far more, I'd say, informative. It's showing us the past 24 hours plus 30 minutes. So at the end of this video is when you're getting a glimpse of the next 30 minutes. It's taking some data and plotting a projection that based on the data on a satellite that is measuring current solar wind speeds and the current situation between the sun and the earth, it makes a prediction as to what's going to be happening in the next half hour. All right, so why don't we just check? So if we were to say what is happening right now, like what is the current prediction, you go to the far right of the screen, and that is the current prediction for the next 30 minutes. So it's calling for an increased probability. Like it's not a zero here, ladies and gentlemen. This is what we're hoping for Nunavut, for Newfoundland, Labrador, and northern Quebec. This is good news. It's not a guarantee of auroras. It is a guarantee, though, that if you look out to the northeast and the skies are clear, maybe, just maybe, you'll see something. There, that was pretty obscure, wasn't it? There's a guarantee you may see something. It's not as sexy when you say it that way. That's probably why the media doesn't cover it like that. They like to say more that it's happening. But if you've lived in the north or if you've seen auroras before, you know there's no certainty, just probability. Okay, so this is what we're seeing on the oval prediction right now. You also see the dark line. You can see splitting Canada and the U.S. there is the line. It's the terminator line, showing essentially where the day and night divide is occurring. So when you press play, you're watching the view in a locked position, a locked view above North America. But here we go. Day is arriving. We're now on to the 18th. You can see now we're about getting towards noon. So the sun, we're now directly facing the sun, and then here comes nightfall. Here comes right now, and the oval is changing. The oval is constantly because it's essentially magnetic forces. It's constantly reacting to the changing flows of energy, the changing particles, the changing turbulence in the magnetic structure. You can see that, like when we look at this oval, it's actually not the oval that's changing. It's the magnetic field that's changing. And what we're seeing is the area where the magnetic field interacts or intersects the north magnetic pole. And so there's a similar video for the south as well. And I can show you that here. So again, when you're on the Space Weather Prediction Center website, swpc.noaa.gov, go and click on Products and Data. And here it is here under Models, the Aurora 30-minute forecast. Let's click on that, and it'll take you to the video for both the North and the South Pole, and specifically the North Magnetic Pole and the South Magnetic Pole. So these are ovals. These are magnetic field structures that are originating from the Earth's core and heading out into space, but they're not heading out as a straight, like a bar magnet. It's the magnetic fields that are heading out in a sort of a donut shape, if you will. Once it reaches the surface of the planet, from the core to the surface, it expands outwards in a conical shape and then goes out into space. And that's when we have the much, much larger magnetic structure out in space. But this is where that magnetic structure interacts with Earth. And so it's referred to as geospace, the area where we have interaction between the geomagnetic field and, the word geo means Earth, basically, or land, or the intersection with the planet. And so a geomagnetic storm is the area at which we have intense turbulence close to the planet. And that intense turbulence that we see as visible light when it's oxygen and nitrogen interacting with particles that pour into the upper atmosphere. And there's a lot of debate about what triggers those active events, but we're not going to necessarily dive into that here, and we should probably get some subject matter experts that know a lot more than I do to explain some of it, because a lot of it is cutting edge. A lot of this research is cutting edge. And there's some really incredible teams working on improving our understanding of Earth's magnetic field. And that's not me, so I will digress it's not my that's not my wheelhouse. My wheelhouse is actually taking the tools that they are creating and then helping all of us enjoy and understand what the tools are sharing with us, and that is that there's a chance you may see auroras. There's a chance you may have a geomagnetic storm. There's a chance that you are going to take a photograph tonight. And how did you get to that moment? Well, it was because we were able to detect activity levels are increasing thanks to those scientists. There's a selfless plug for all scientists in the field. Okay, so what are we looking at here? This is the South Pole, the South Magnetic Pole. Earth is rotating there. You can see again the day and night divide, the terminator, as it's called. And the oval is, maybe one way to think about it is the oval is staying in one place. It's the Earth that is rotating underneath the oval. So sometimes we just think everything orbits around, like everything is focused on us. But in fact, we're rotating on a large rock, which is actually a tiny rock relative to everything else in the universe. And that rotation means we have a day and a night. And on the nightward side, there's an oval that is constantly fluctuating based on the energy that pours in and out of the Earth's magnetic field system, geomagnetic field system. And so when we are at the right time, at midnight, the point at which we're directly opposite of our star, on the nightward side, we are extremely well positioned to see the northern lights because that's exactly where the oval is positioned. The most turbulent area of the oval, the most turbulent area in the magnetic structure from an aurora viewing point of view is at local midnight. When it's midnight where you are, you're on potentially the optimal spot for viewing auroras because there's a potential for turbulent activity. That's why when you see these elevated levels, they're not occurring around the perimeter. They're occurring in the sort of the thicker area that is directly opposite of the sun. It's a lot like I like to use the analogy of a boat. It's like the turbulence behind the motor. So we have the front of the boat facing the sun, but the back of the boat is where all the turbulence is, and it's kind of the same idea. Okay, so that's what's going on the South Pole right now, and if we were going to fast forward to the very end of that video and just show the current 30-minute forecast for the north and the south, there you go. The next 30 minutes shown right there is what they're predicting. So that's good. It shows a little bit of an elevation in activity. For the next tool, we'll check out the... we've already looked at the WSA NL solar wind prediction model right there. I was going to take you to the real-time solar wind. Let's go to ACE data. There are a couple of different satellites that can help us with this. Maybe I'll go to the Discovery satellite. So the ACE data, yeah, let's go to Discovery. ACE is the older model or the older equipment that was used to measure the speed of the solar wind. Maybe where do I find that one here? Hello, Discover, where are you? I know somebody can see it right now, and oh, there we go. Real-time solar wind. All right, this is better. This is from the Discover satellite. And I don't know how clear that is for you, but it gives us a really cool view of the timelines. This is a one-day window. So the past 24 hours of the solar wind conditions at the Lagrange point. That is where the satellite is located. Lagrange point is an area where the gravity of the Earth and the gravity of the sun are both tugging on the satellite equally. So it stays in one position. It doesn't fall in either direction. And it's directly between the sun and the Earth. It's not halfway. It's just at that point where the gravity holds it there. And so why that's important is think of it more like it's a buoy in the ocean. And that buoy gives us a heads up if it gets impacted by an incoming gust of solar wind. We can see it on these charts. And so if you haven't seen this before, I really recommend you go to the Space Weather Prediction Center website and check it out. And the couple of key things to watch. So remember we were looking earlier at the WSA Enlil solar wind prediction model. And when we were there, we were looking at solar wind density and solar wind speed. And I don't even know if I highlighted the speed, but the speed was the pinwheel at the bottom. Density was the pinwheel at the top. That was the prediction. This is monitoring the data. This is monitoring what actually happened. So to check that out, we go to the speed. This is a little bit congested here. I'm wondering if I'm zoomed in. Oops, what did I press? What did I press? There we go. That's a bit better. So the yellow line, the yellow box, which is, it says 590 there. 561 is that. That's indicating the current solar wind speed, which is elevated. Usually the solar wind is hovering between 200 to 400 kilometers per second. So we do have a faster moving solar wind right now. And it's been going on like that for over 24 hours. You can see we've been in the 500s in a pretty consistent way. 550 was the prediction for the first coronal mass ejection. It was going to escalate to 550. It's surpassed that a few times. The new prediction is that it's going to be going up to 700 kilometers per second. I believe I saw that on the previous model we were looking at. I'll go back to that in a second. But anyway, this is where you go to see what's actually happening with the solar wind speed. And as far as whether or not there's significant plasma density, that's the line right above it. So we can see it is flatlined, pretty much flatlined for the past 24 hours at around 10, between 10 and 12. Why is that significant? Well, if you have a particularly fast-moving solar wind and it's really dense, it can lead to a much more significant impact on Earth's magnetic field. So what are we watching for? We're watching for spikes. Like intense spikes in this data is a telltale sign that something has passed the satellite and is on its way to Earth. And it takes about 45 minutes, 30 to 45 minutes for something that has impacted the satellite to reach the Earth. If it misses the satellite, it'll miss Earth. That's kind of the thinking around this. So we're watching the satellite, it'll give us a heads up, and then we get our cameras, we run outside, and we get ready for a nice light show. This is why we're doing this, ladies and gentlemen, so you guys can have the tools you need to succeed tonight if we have that really intense spike. Where do we see the spikes? Because there aren't any on the screen here. I wonder if I can just go back in time a bit here. I'm going to do a three-day look at the situation to put things into perspective. So we just looked at a one-day perspective. And take a look. There are a couple of places to look. So first of all, look at the solar wind, 366 a few days ago. And then suddenly right here on the 17th, we had a spike. It started to rise. The solar wind speed started to rise, but it wasn't a major spike. It was sort of a gradual spike. But take a look at what's happening with that yellow line. It's trending upwards, trending upwards, trending upwards. All right. Well, while that's happening, look at the top line. The very, very top is where we see the BZ indices. And what it's referring to is Earth's magnetic field, the polarity of Earth's magnetic field. And why is that important? Well, when the polarity is tilted north, in other words, that predominantly our magnetic structure is northward facing, that's not good for aurora viewing. When it's southward facing, and it tips to the south, that means really good chance of auroras. How do we see that on this chart? Well, pretty simple. If the red line, as we see here, I'm going to see if I can get even closer. See if I can get closer. Can I get closer? I don't know. Oh, it's trying. It's trying very hard. Okay, I think I just messed that up. Let me just take it back a step. All right, we'll try this. If the red line dips below the zero marker, you can see the zero marker as that solid white line moving across the chart. If the red line dips below, guess what? It means auroras. It's not a guarantee. It just means that those are the conditions for a nice show. And even if it's just slightly below the 0 mark, it's an indication that the conditions are right for auroras. Get outside, grab your camera and go outside. And it's ideally, we're looking for an intense spike. So did we see any? Well, we did right there. You can see on the top of the chart a jump upwards, but it was upwards is bad. We want downwards. And so, well, where do we see that? We see one there. We see another one there. And there. But those aren't really intense events. Those are kind of just unsettled turbulence in the magnetic structure. It's unsettled behavior. It's leading to auroras. There were auroras visible. Highly likely auroras were visible as a result of those at those moments. But check this out. We see a dip, another one, and then, wow, all the way down to a negative, where does it say? -16, -17, tilted south. And that is great news for aurora viewing. And that was the G2 event that occurred above Scandinavia yesterday. And then we fast forward to our current situation, and we're seeing that we see some G1 events. This is likely the G1 activity from earlier today, and we're getting closer to now. And we saw that there were G1s happening even with these events. So that's just telling us that it was a residual turbulence, I suppose. But here's the good news about that. Is it doesn't take a lot to trigger active auroras. It takes a lot to trigger a G2 or G3 geomagnetic storm. So hopefully that helps explain a bit about how to use these instruments and help us better understand what's happening in real time. So that is the Discover satellite. It replaced the ACE satellite. I used the ACE data last night, I believe, and tonight we'll use the Discover. It's a great tool. Now let's go back and now that you know what we're watching for in real time, let's go back to the solar wind prediction model quickly. And there we go. So this is our solar wind prediction model. On the bottom, we see these gusts of solar wind launching outwards from the sun. And the red is an indication on the bottom of fast-moving solar wind. And the reason I bring that up is we look at the arrival time on the right, the 17th, the 18th, the 19th, the 20th, and the 21st. There is a significant gust of solar wind expected to arrive late on the 19th, is what this is telling us. I'm going to stop it and go back to the next CME arrival time. And that's when we're going to see a spike in the speed. And how do we use this to detect the speed, or the predictions around speed? Is that it is the top chart on the right, and it's showing again a linear representation of what's happening on the left. So on the left, the sun is at the middle. It launches these gusts of solar wind out into space, and the arrival time for those gusts of solar wind is predicted to be at approximately 1800 universal time on the 19th. And unfortunately, that's during the day. What we're hoping for is that it's a late arrival time, or a really, really, really early arrival time, which would be good for Western Canada tonight. That would be awesome. And so we're kind of banking on hoping that their predictions were wrong. If you're just tuning in, you're listening to James Pugsley. I'm with the Astronomy North Society. We're based out of the Northwest Territories, and we are holding our second ever Aurora Astronomy North live event, an Astronomy North NowCast. And we're covering the current geomagnetic storm predictions for tonight, tomorrow night as well. And the expectation was that there could be upwards of a G3 strong geomagnetic storm. It didn't happen last night, and it's not likely to happen tonight. They downgraded it to a possible G1 or G2 for tonight. And we actually have already seen a couple of G1 events have occurred in the past few hours. So that's good news. It's just it's not dark yet in Canada. It's getting there in Eastern Canada. Sorry, you're getting there in Eastern Canada. In Western Canada, the sun is still out. So we hope that you are going to start to see some activity shortly. So with that in mind, I'm just going to turn on a few of our other features here quickly so we can take a quick look at what's happening with our incredible Aurora cameras that are located across Canada. Now, there will be more Aurora cameras coming online in the coming weeks. The Aurora Max camera in Yellowknife is not yet on. It should be on in the next few weeks, and that'll give us an awesome view from Yellowknife at 68 degrees north magnetic latitude. It's a perfect location for documenting auroral activity because the auroras are visible at that magnetic latitude almost every single night. Churchill, Manitoba is at the same magnetic latitude, or very close to that magnetic latitude, so there also is a great camera for us to monitor, and that camera is on. And so let's just switch over to our live feeds. And as we see, it's still light in Churchill. And we're hoping that tonight that cloud cover disappears. That's the hope. And the Churchill camera is a great camera. It is explore.org is behind that camera and helped install it in Churchill. And it's been amazing. And what a great tool for learning and a great tool for observing. The resolution of this camera is, as far as I'm concerned, it's unprecedented. And it's just a standard camera as far as I understand. I think it's just it's a high-powered SLR, is my understanding anyway. If anybody from Churchill is on the line right now, feel free to correct me. But I think that it is controlled by the folks at Explore. And when they mounted it on the roof at the research facility in Churchill, I don't think we all knew exactly how that would go, but we certainly appreciate the quality of this camera. It comes with audio as well. We can turn the audio on. But this broadcast tonight, this NowCast, isn't about one camera. It's about looking at all the cameras. And for that, I wanted to actually highlight the array of cameras that's in the bottom right. Themis Canada is a really cool project led in Canada by the University of Calgary and the Canadian Space Agency, and in the U.S., the University of Berkeley, California, and NASA. And that project was created to explore magnetic reconnection and geomagnetic storms, and particularly substorms. I mean, I don't think they were isolating substorms versus geomagnetic storms. Rather, they were looking at the cause and effect. So if they could detect something out in space, they launched some satellites that sit in orbit at particular magnetic field lines. And so when a magnetic reconnection occurs, it's when essentially lines in the Earth's magnetic field basically cross. And as a result of that, it launches particles towards the Earth's northern and southern magnetic poles. And that's what triggers these waves of auroras, these in periods of intense activity or increased activity, is due to these magnetic reconnection events. Well, it was Themis that helped make the groundbreaking discovery that proved this was happening. And the way that they were proving it was by showing the data from space combined with Earth-based observation. And so each of the circles on that Themis Canada map represents a camera that was set up by the University of Calgary across the north and into Alaska. I believe they originally had 33 cameras. I could be wrong. But it's a great project if you're really kind of keen on just observing the coast to coast to coast auroral activity, which is really awesome. When we have a geomagnetic storm, oh man, that camera lights up. It's not one camera, it's all those cameras light up, and you can watch the east to west and north to south movement of the northern lights. And every now and again, you get those moments where all the activity goes quiet, and then you can see one arc. And the arc, if we're lucky, it happens when it's dark in Canada, dark in Alaska, and you can see the arc from across the north push south. And it's an amazing, amazing thing to watch, because it's telling us that is the onset of a geomagnetic storm or of a substorm. But generally speaking, if it's pushing south, that far south, and then it has a big release, that's the onset of a geomagnetic storm in many, many cases. So that being said, we're watching those cameras tonight. They're black and white cameras. They're situated across all the way from Greenland over to Alaska. A number of the cameras are currently not on. If they're blue, the light blue, it means they're not on. And that's for two reasons. One, it may be having technical issues, or two, it's not dark enough yet. So we should start to see a few of those cameras come online shortly. And we can see that it's still daylight in Churchill. So I've been talking for almost an hour, and I think it's probably best that I take a bit of a break and get some nourishment. But I'm going to keep these cameras rolling, and I'll be back in an hour. So unless there's something enormous that happens. So the goal is I'll be back online at, it'll be 8 o'clock Yukon time. And that means 8 o'clock in BC, 9 o'clock in Alberta, 9 o'clock in the Northwest Territories, 10 o'clock if you're in Ontario. Sorry, no, that's wrong. 11 o'clock if you're in Ontario. And so if you're up, keep checking it out. We're going to have some live feeds going here through the night, and hopefully we all get to see an aurora tonight. And if you want to send any comments or send any messages through YouTube, please do so. I look forward to getting your questions. Or you can send an email to info@astronomynorth.com. All right. We will see you at 8 o'clock Yukon time. So that is 11 o'clock Eastern. Signing off for now. See you soon. And we're back. Welcome, Northern Skywatchers, Southern Skywatchers, Aurora photographers, scientists, media, everyone. Welcome. It's an Astronomy North Nowcast. We are broadcasting live from Whitehorse, Yukon, and the Astronomy North Society is offering some new online features this year, including these live events. Thank you for joining us. I'm James Pugsley. I'll be hosting this event for a little while longer. And the goal tonight was to give you guys a bit of an idea of what's going on with the Northern Lights tonight. And we were basing this Nowcast on the fact that there were significant events going on the sun earlier this week that launched Earth-directed coronal mass ejections at Earth. So where else would an Earth-directed event be? At Earth, of course. So when the original predictions came out a few days ago, it was that there was going to be potentially a G3 geomagnetic storm on Earth. So these waves of particles coming one after another were going to trigger turbulence, significant turbulence in Earth's magnetic field. And that turbulence would then, of course, lead to what we're all about, which is aurora viewing. Observing the sky, but also observing some pretty amazing phenomenon which tell us a story. The auroras tell us a story about something that occurred on the sun days ago. It took a couple of days, usually 2 to 4 days, for solar winds gusts to reach the Earth. When they finally arrive, they interact with Earth's magnetic field, and the magnetic field will send a number of particles towards the north and south magnetic pole. And as a result, we get this incredible light show where oxygen and nitrogen in Earth's upper atmosphere become illuminated by these charged particles, electrons and protons pouring into the upper atmosphere. Well, here's the thing. The prediction was that there might be a G3 storm because there were multiple waves coming at Earth. And in any situation like that, it is always best to err on the side of caution if your entire mandate is oriented around industry. If your if your mandate is industry and your goal is to help protect satellites, to help protect the aviation industry, people who are dependent upon GPS systems, to help the military be better informed of possible disruptions and radio frequencies and disruptions to GPS, then announcing that it could be a G3 is definitely a good thing. Unfortunately, from an aurora viewing point of view, we get really excited. G3 storms mean potentially long duration auroras. We could have many hours, sometimes a couple of days of auroral activity because it takes that long for Earth's magnetic field to settle back down again after those wave upon wave of turbulence. Anyway, here's what happened. Nothing really happened. And that's not out of the ordinary. When that occurs, there's a big announcement that there's going to be a geomagnetic storm, but we don't look into the details. The details told us in actual fact that there was a good chance that those coronal mass ejections were just going to miss Earth entirely. But the predictions were based on the fact that what if they didn't miss? What if they delivered a glancing blow to the magnetic structure? You don't want to, catch industry off guard. So I want to just give a shout out to the Space Weather Prediction Center at the National Oceanic and Atmospheric Administration because they're going to get a lot of criticism. They get a lot of flack from the aurora community when perhaps it's not really what we should be doing. We should be acknowledging that they gave us a heads up that there were some coronal mass ejections coming and that there was an increased probability of a geomagnetic storm, and we have technically had a couple of geomagnetic storms. In fact, just a few hours ago, there were about 6 hours of G1 level magnetic storms. G1 is a minor storm, and G2 is a moderate, and we had a G2 storm yesterday. So they're not wrong. It's just people focus on the G3, which was only planned
only forecasted to occur over one 3-hour window. But when you look at it on the website, it looks like all of the 18th was going to be a G3, when in actual fact, it was just one little 3-hour window where they predicted levels may increase enough to cross that threshold and become a G3 strong geomagnetic storm. Anyway, there's a lot of technicalities here. The point is the aurora is mysterious. The Earth's magnetic field, it's mysterious. And the sun can be mysterious. I shouldn't say that the whole sun. Some of these areas of interest have still got a number of variables that leave us scratching our heads. As you can predict, for example, that after an eruption on the sun, you can predict that, hey, it's heading towards Earth. But by the time that cloud of particles, that gust of solar wind, reaches the Earth, it may or may not be on the exact trajectory that you thought it would be. And it may sweep past the Earth, but it may miss the Earth entirely. Or, it might be like a big donut shape, and there's a hole in the middle, and it sweeps right past our planet, and we went right through the hole. And we never even knew it. And so it's a tough job being a forecaster, to be a space weather forecaster, I should say. It's actually kind of an easy job to be an aurora forecaster. And that's my role. I'm a volunteer. I help out the Astronomy North Society. I've been doing the aurora forecast for northern communities for years. And one thing I've kind of learned is the global forecast and the northern aurora forecast are two very different things. It's actually quite easy to predict auroras for the north because they happen almost every single night, whether the sun is active or not. We are seeing auroras above Yellowknife. We're seeing auroras above Dawson, Churchill, Iqaluit, almost every single dark night. Why? Well, because of where these communities are situated on the Earth, and in particular where those communities are situated relative to the North Magnetic Pole. So any community that is in the neighborhood of 67 to 69 or 70 degrees north magnetic latitude is extremely well positioned for viewing auroras almost every single dark night from mid-August until mid-May. And we see that because almost every single night we have one, maybe two substorm events, which are isolated periods of turbulence. They're very localized. You may have a surge of activity suddenly occur when it's midnight in the Northwest Territories. And almost every single night around midnight in the NWT, give or take a few hours in either direction, we have a substorm event. And then guess what? About 4 hours after that, there's another one. A breakup, it's often called. And the lights brighten and the sky turns green and lots of dancing purples and crimson. I love using that word, crimson. And then it'll settle down. And guess what? 4 hours later, it'll do the same thing. And then during the day, 4 hours later, it'll do the same thing, but it was so bright you couldn't see it. It's just the way our magnetic field works. It's got its systems. It's got wash, rinse, repeat. If you were to look at it in a very general sense, it's wash, rinse, repeat. Even if there's no enhanced solar wind. The ambient solar wind combined with the magnetic field's own processes contribute to a regular supply of incoming charged particles and therefore give us a chance to see auroras almost every single night. Okay, so the bottom line is the storm prediction was unfortunately, it doesn't look like it's coming true. But just in the past hour, so I took a break for just about an hour and came back to the microphone 10 minutes ago, and I see something major has happened. So it's breaking news. And the breaking news is that NOAA and the Space Weather Prediction Center have now revised their forecast. Again, they've revised it because they can see now that it looks as though their prediction, even for tonight, is not going to come true. Not that that's a bad thing. It's not a criticism here. It's just that the warning that they issued, the Geomagnetic Storm Watch, looks like it may have been lifted. Either the particles missed the Earth entirely, or it's been there's evidence to show that maybe the impact already occurred and it was insignificant. We only got a small portion of the coronal mass ejections. Let's take a look at the instrumentation that tells us what's happening there. And so for that, I'm just going to click a few buttons here, and we're going to look. That, by the way, the camera that we're looking at there is live from Churchill. The sun is finally setting. And so that means we're looking to the northwest. Last night I was thinking we were looking to the northeast, but this is proof that it is not the northeast. It is looking to the northwest. And perhaps actually just directly to the west. Okay, good to know. I love it. I love it when the evidence proves me wrong, like right to my face. It's way easier that way. Oops, I'll keep that on. Okay, so I'm just clicking a few buttons here. Please hold, ladies and gentlemen. We're getting to our... okay, that's what I wanted to show. The WSA Enlil prediction model. So we looked at this earlier as the tool that is used to help us see what the forecasters suggest will be happening. So here's earlier, if I'm just going to switch over. Here we go. So this is the WSA Enlil solar wind prediction model. So it's basically telling us the arrival time of these gusts of solar wind. So earlier, just an hour ago, this looked very different. It had two major spikes, including a spike around the 20th, I believe, late on the 19th. That was the next anticipated CME arrival time. And look at it now. So where I'm looking is I'm looking at the graph on the right, the charts on the right. So we have three lines: the green line, the red line, and the purple line. And so to try not to confuse things, we're going to focus on the green line. The green line represents, we'll start with the bottom chart. There are two charts there, one on the top, one on the bottom. The bottom chart refers to the radial velocity, let's just say speed of the solar wind. And the chart on the top refers to the density of the solar wind. The green line represents Earth. So what is happening at Earth? And when we measure the solar wind as it basically comes towards Earth and passes Earth, this is what the predictions were going to be. This is what the predictions are, is they're suggesting that the solar wind speeds are going to be 300 to 500 kilometers per second over the next few days. For the second line, the red line, that is the same data at a different point in the solar system. It's where this satellite is located, this stereo A satellite. And then the third line is the stereo B satellite. So they're all plotting the same thing, just from different positions. So we don't need to focus on what's going on with stereo A and stereo B right now. We can see them, all three items, all three objects are identified on the pinwheel on the left. So we'll start bottom left-hand corner. You can see this beautiful pinwheel. What is that? Well, at the center of that pinwheel is a dot that is the sun. And now imagine we're looking at the sun from overhead. And then we see these three dots to the right of the sun on your screen. Two of those dots are a satellite, and one dot is the Earth, and it's the dot in the middle. Technically, those are three satellites. The Earth is a satellite of the sun. And all three are detecting space weather or detecting solar wind as it passes by. So the prediction is, we'll follow the green line on solar wind speed, radial velocity. The prediction is currently now that the solar wind speeds will be ranging between 300 and 500 kilometers per second and are trending now down. And so this is different than the prediction an hour ago. So they've just updated it. And unfortunately, ladies and gentlemen, an hour ago, the prediction was the Earth was going to get hit, sideswiped by a flank of that solar wind. Where is it on this pinwheel? Well, you can see little eruptions popping out of the sun. These little eruptions that are easier to see on the little sort of next to the pinwheel, there's that sort of a semicircle. It's not really a semicircle. I've got to figure out how to call that. It's like a cone, a conical shape. I don't think it's a cone either. Anyway, you get the idea. You see those red bursts? That's telling us a different story using the same timeline of what's going on the left. So on the left, we're looking at the solar system from above. And then the second little smaller visual is showing the solar system from the side. And guess what those clouds are doing? These bursts are coming from the sun are missing the Earth to the south. So imagine you're looking at it on the plane of the solar system with the green dot being the Earth. Those red clouds are missing the Earth. An hour ago, they were hitting the Earth. And they were visible on the left-hand side on the pinwheels as more intense incoming gusts of solar wind. So that, ladies and gentlemen, is what has changed. They've done their calculations again, and now they're projecting that the coronal mass ejections are going to miss Earth, and therefore there will not be a geomagnetic storm in their forecast is suggesting there will not be a geomagnetic storm. It doesn't mean there won't still be a geomagnetic storm. We've already had a couple of G1s today and a G2 yesterday. So there's still an incremental turbulence that could trigger geomagnetic storms tonight. But this is kind of big news. This is big news for aurora chasers. It means you can now go to bed, especially if you're in the East Coast. If you're in southern Canada and you're planning to stay up late for potentially another eventful night, unfortunately, this is suggesting that we will not be having that eventful night. So it's good to know. Hey, at least they're honest and telling us before we did the full all-nighter again. Last night was a long one, but it was cool to just follow the data, watch the feeds, and see what we could see. So let's take a look. So I'm just going to scan our Space Weather Prediction Center website again. We'll just do a quick check of where we're at. So we're going to the home page, and you can see again solar wind speeds currently are at 565 kilometers per second, but it was supposed to spike up to 700 kilometers per second by tomorrow midday, and that would have been a pretty serious boost to the solar wind. So that would have potentially caused some significant geomagnetic storm activity if the particle flow was dense, and if it was fast moving. That's what causes this turbulence in Earth's magnetic structure as these solar winds sweep past. So we're going to take a quick scan. So they have updated. It was previously G2. Now that they were predicting for the next 24 to 48 hours, now it is modified to reflect the new reality. So they're suggesting that on the 19th, possibly a G1 geomagnetic storm in the forecast, and now on the 20th, possibly a G1 geomagnetic storm in the forecast. So that is a very different forecast than we had even just an hour ago. Thank you, though, to the Space Weather Prediction Center for the work that you're doing to monitor the situation and give us the latest information, because part of this is to try and save everyone from going out blind. We now know that they're downgrading it. So in southern Canada, sorry for this news. It looks as though the big show will not be happening. It looks as though we will still be potentially getting a few of these red bars in the next 24 hours. It's still possible. The red bar represents a G1 minor geomagnetic storm. Still a great event. Still means auroras above at high latitudes, and it means auroras at the northern part of the prairies. It means auroras may be visible northern BC. And where else would be a good place to be for G1? Churchill, obviously Churchill, Yellowknife, a lot of northern locations. You're going to still get a good show, but temporary northern lights at southern latitudes at best, and even then, it's mostly the prairies that would have the best opportunity to see G1 events as they sweep down from the north, illuminate the skies, and then come back to the north. So right now we're seeing conditions are relatively quiet. We are seeing that the forecast is becoming a little bit more conservative, and it's suggesting that the big show is not going to happen. So I think what we'll do here is I'm going to keep cameras rolling because why not? And we'll just leave it rolling for another hour. So probably shut it off at 9 o'clock Yukon time, which is midnight in Toronto and Ottawa and Southern Ontario. And so we'll keep it going just so you guys can see some of the cams, the webcams, and watching activity from Churchill in real time. There will be more webcams coming online over the next few weeks. So the purpose of this Nowcast is to take a look at those webcams and watch the aurora as it sweeps across the country. And we're going to monitor weather. We'll monitor social media. The hope is that we'll create a new buzz, a brand new buzz, so we can all enjoy the auroras in real time like never before. Check out this, though. I've got this posted on, this is from the Space Weather Prediction Center website, and it is the current 3-day outlook, and this has changed. It's probably going to change again by tomorrow morning, too. They update it every few hours. Sometimes it's 10 hours, sometimes it's 6, and I think during storm events it's a little bit even more frequent. Click the wrong button there. Let's just switch that. Sorry. And so what are we looking at? Well, if you take a look at the August 19th, this is referring to universal time. So there's a 7-hour difference between universal time and Whitehorse, and 6 hours for Yellowknife. So you get the idea. That 0 to 3 o'clock on August the 19th is actually 6 to 9 on in Yellowknife p.m. So that's around the time. So if we see a 6 here, the 6 is telling us that KP levels or storm levels, or sorry, I mean, let's just say KP, because KP is the index to measure intensity of geomagnetic activity. So when we see a 6 is the equivalent of a G2 storm. A 5 is the equivalent of a G1 storm. Actually, maybe what I'll do is that's the geomagnetic forecast. I'll put it on the, I'll put it on the 3-day forecast. I think they actually articulate it. There we go. They articulate it here. A 6 is a G2, a 5 is a G1. And look at that. So the prediction is that tomorrow night, between 6 and midnight, there is a chance of increased geomagnetic activity, meaning we could have some nice early auroras on Friday night for Canada. So if you are out and about, if you live in Alberta, anywhere in Alberta, Saskatchewan, Manitoba, Northern Ontario, Northern Quebec, Northern Newfoundland, Labrador, and Northern BC, Central BC, heads up tomorrow night. There could still be some geomagnetic storm activity. However, based on what their projections are, this could change. This could change a lot. And they could just simply be a KP3, KP4 kind of a night tomorrow night, which is good for the north. We'll see auroras in the north, but unfortunately for southern Canada, you may not get a show. So I just wanted to show you guys what's happening. This is as close as I guess you can have to breaking news in the aurora photography, aurora science community. But I'm glad we know. At least we know. And without further ado then, so what I'll do is I think I will sign off around midnight Eastern, and that is 9 o'clock Yukon time. And so I'll just give you guys right now my appreciation for joining me today, joining this Nowcast, Astronomy North's second ever Nowcast. And we're going to keep building on this and keep developing so that we have new features and live interactive feeds. And I've got to learn all this software because this is all new to me. But hopefully you enjoy the concept and that we can continue to build on it. And we're going to have, as I said earlier, more and more tools at our disposal, including when some of the cameras come back online, cameras that were instrumental to observation at high latitudes for sure, like the Aurora Max camera in Yellowknife. So it's scheduled to be online shortly. I think we're looking at early September, so a couple of weeks from now. And then these geomagnetic storm events will have multiple cameras that we can explore and talk about whether or not there's going to be auroras visible above your community in real time. So without further ado, maybe I'll just sign off. Thanks everyone for joining. If you're looking for more information on Astronomy North, I recommend checking out our website. It's astronomynorth.com. We provide a daily aurora forecast every single day. That's what a daily means, James. Come on. We have a daily aurora forecast for 9 northern communities. And we just added Fort Smith this year. So the 9 communities that are getting their daily fix of aurora will be, it is Yellowknife, Hay River, Fort Smith, Inuvik. In Yukon, it's Dawson, Whitehorse, Watson Lake. And then where else? We have Churchill and Iqaluit. And it's exciting. These aurora forecasts are visible, like they're there to support communities that are located under the auroral oval to help families improve their connection to the sky, and also help families get out and enjoy the show. That's the whole idea. We just want to help people stay connected to Canada's northern sky, and if we can help also with, if you have questions, if you're looking for information and want to learn more about any of the topics, any of the projects that we're leading, please send an email to info@astronomynorth.com, and you can direct it to me if you'd like, James Pugsley. Thrilled to get your emails and looking forward to doing more live events this year. I think it's going to be a really interesting year. We're starting to trend towards the peak of the solar cycle now. The low end of the solar cycle occurred December 2019 was the switch. We saw the big switch to a reverse polarity of sunspots that we saw that was the indication that the new solar cycle 25, had begun. Now, that being said, I'm just looking at the live feed for Themis Canada. I am seeing what appears to be an arc. Yes, we do have auroras now. Geez, just as I'm going to sign off. Isn't that always the way, eh? So we do see auroras now above Hudson's Bay, James Bay, northern Quebec. And so this camera, this live feed that we have here on the left is from Churchill, Manitoba. And we're not yet seeing auroras because the camera is facing west. But if you look on the Themis camera, which I'll blow up to a larger size here. If we look on the Themis camera, which is showing the whole country, it's showing the whole country with a series of cameras all combined to make for one large array. And I'm just bringing it to the top here. It'll be a little bit out of focus. It's not the largest visual. It's a lot of small images coming together to form this large array. So it leads to relatively low resolution imagery. But here we go. So this is telling us right now that there is an arc forming across northern Newfoundland, Labrador, northern Ontario, and northern Manitoba near Churchill. And so to be honest, actually, that's not northern Manitoba. That is central Manitoba. So if you're listening right now, if you're in Winnipeg, you're looking north right now. There is a camera, actually, I can see at the south end of Lake Winnipeg, though. And so each of these circles is a camera. The blue circles are indicating that the camera hasn't come on yet, which means one of two things. Either it's not working, which happens, or it's not dark enough. So chances are it's dark enough because the other cameras that we can see, one in Newfoundland, Labrador, one in Quebec, and then one is appearing near Churchill. I don't know if it's Rabbit Lake, Saskatchewan. No, it wouldn't be Rabbit Lake. It's probably, I don't know if it's Churchill or not. I will find out. I'll talk to the Themis crew and see if I can learn the locations a bit better. I'll be doing this quite a bit, I guess. But this is telling us that there's an arc right now forming coast to coast to coast. No, not coast to coast to coast. It's forming east to west. And you can see it now quite clearly in the central camera there. The central camera is telling us that it's intensifying, and that's a pretty good location as far as the magnetic field goes, that it's telling us it's actually it's pushed a bit south of Churchill. So that's suggesting that there is a relatively, decent situation unfolding right now, that there could be a breakup shortly, a breakup meaning a substorm event. And so let's just keep an eye on this. And we're going to also want to keep an eye on the Churchill camera. So let me see if I can pull the Churchill camera back into view. And we're going to start to watch in real time for auroras to appear overhead and to the west of Churchill. And unfortunately, I think, it's still bright to the west there. So it's going to be, hopefully, you can see it's intensifying now on the Themis imagers. So hopefully we can see this intensify and push a little bit further north so it'll appear above Churchill. I'm going to now switch. Oh, no, I think I'll leave it. I'm just going to leave it for a bit longer on. I'm just going to leave it for just a little bit longer on this view, so you guys can see what I'm talking about with the arc and the changing lights. So if you're not sure what I'm talking about, like where are you seeing auroras here? There's nothing green, James. I don't see anything. These are all black and white cameras. So there's an array of about, it originally was 33 cameras from Alaska all the way to Greenland. Some of the cameras are not online right now. That's the challenge. Some of the cameras have not, they're having technical difficulties. And so, it's probably just technical difficulties. And so those are going to be resolved soon because there are crews heading to these cameras right now to try and get them all back up and running. So we're a little bit early in the aurora season, to be honest. And that's why some of the cameras aren't up and running. That's why Aurora Max isn't up and running. In the north, it's been bright for the past few months. So we're finally just getting to the point that there's darkness again. And I don't think anybody was expecting there'd be a live event with featuring auroras and using cameras from the north in the middle of August. But here we are. So look at that aurora what we're looking for is areas where we see brightening on these black cameras. Where you see the sky is black, it means it's actually dark. Where you see that the sky is kind of fuzzy or gray, that likely means that there's cloud cover. And especially because there's a moon out tonight, the moon will illuminate the clouds. We're not seeing the moon yet in the images, but once the moon comes up, all of these circles will have a new bright dot in it because they're all seeing the moon at a kind of a different elevation depending on where they are in the country. But as the moon rises, they will all have a little dot, a very bright dot. Oh, we just lost the feed from Calgary. And then it's back. Okay, good. Now we just lost the feed from my desk. Okay, here we go. So we've got the two cameras going here. Themis Canada is a project launched as a partnership between the University of Calgary, the University of Berkeley, California, NASA, and the Canadian Space Agency. It combines satellites with ground-based observatories, and tonight we get to enjoy the show thanks to these ground-based observatories. What is it telling us, though? What is the show telling us? Well, the show is telling us that it is currently about midnight. It's currently about 11:30 Eastern. It is 8:30 in Yukon, 9:30 in Yellowknife. And it's now telling us ultimately that we're probably in for an active show earlier than usual because there's residual plasma, there's residual energy, let's go with energy. There's residual energy in Earth's magnetic structure right now from the past 24 hours. So the wobbling, the turbulence is leading to the chances for enhanced auroral activity tonight for high latitudes. And ladies and gentlemen, I can see auroras in the Churchill camera now. Can you guys see that? So this suggests the camera is facing southwest, and you can see an arc forming right before our eyes in Churchill. At the same time, if we look on the Themis imager, we can see an arc, pretty much the same location, I don't want to suggest that these are both in sync, these cameras. And here's why. The camera that is the Churchill cam was installed by Explorer.org. It's an incredible camera. It really is. It's doing an amazing job to catch not just auroras, but look at the stars. Like, we're actually seeing stars. We're seeing details on the radio antenna even. It's an amazing camera. Love it. Thank you, Explorer, for installing it. Thank you to the crew also that manages the camera, because they can pivot this camera. If it's going to be a particularly active night, you can actually see them shift the camera to another direction. And so when they do that, you get to see, different areas of the sky, and sometimes they pivot it or on its axis so it's looking straight up, and you get a great show. Well, right now we're looking to the southwest. The sun is going down, and that was the clue that we're looking west. We can see some buildings in the foreground in Churchill. We can also see the aurora appearing above the western horizon. And so if we were to compare that to the imager at the bottom of the screen, bottom right-hand side of the screen, it's also showing us an arc. And that arc, we just saw that arc was above Quebec as well. It's all connected, but if you look at the clouds, if you look at the camera in Quebec now, it's looking a bit cloudy there. How can I tell? Because the whole camera is kind of turning gray. And that tells us that there's something is illuminating, and it's likely clouds getting illuminated either by the moon, which may be rising shortly. I haven't checked on that. Don't hold that against me. I don't know exactly what the moon rise is right now. Anyway, the point being is something is illuminating the clouds. It may actually be the aurora intensifying that's illuminating the clouds, but we're not seeing the arc on that one camera above James Bay, Hudson's Bay, because of clouds. To the east is Quebec. We can see that there are lights now above northern Quebec and Labrador. Chances are you may not be able to see that if you're in Montreal or Quebec City right now, because the nature of this brightening it's not that this is a serious or significant geomagnetic event. Rather, this is just sort of the standard substorm event, the standard brightening that we see about every 4 hours. It looks like it's a bit enhanced, so that's good. So we could have some tall pillars of light. But to see this sort of show from southern latitudes, mid-latitudes, it has to be a relatively tall aurora. And you look to the north. If you're in Minnesota right now and you're trying to look for auroras, you're looking to the north, and you might be able to pick up what's going on in northern Manitoba, just the top of that aurora, due to the curvature of the Earth and the fact that the aurora is basically 100 kilometers up, but can be as tall as 400 or 500 kilometers tall. So when it is 500 kilometers tall, that's why you can see an aurora across the border looking towards Canada. You'll see these tall pillars of light. And sometimes when you go on to, social media, you say, oh, the auroras were visible above Michigan. Technically, they weren't above Michigan, but they were visible from Michigan. But why get into that dispute? There's no point. Anyway, look at the pillars. We can start to see some pillars, some structure in that the arc that's formed above Churchill. So this is exciting news. It means that there is still going to be lots to look at tonight. It's just not going to be a major geomagnetic storm event. So if you're in southern Canada right now, we just got news around 8 o'clock Pacific time that the forecast has changed. It is now going to be a much more conservative forecast. I'll put up the details here. On the CME arrival time predictions are now significantly altered, significantly enhanced, significantly downgraded. That's the best word. That's the best word. It's been downgraded. We are no longer expecting a significant impact from a CME, coronal mass ejection. We are expecting solar winds to be between 300 and 500 kilometers per second over the next few days. And we can also expect that there may be some G1 or G2 storms in the next 24 to 48 hours. Still possible. Still possible. It's still possible tonight that we'll have a G1 geomagnetic storm. We had some a few hours ago. There was a 6-hour period there of geomagnetic storm activity. However, it really does tells us that things are shifting back. Oops, that was the wrong button. Things are shifting back to being a little bit more stable in the Earth's magnetic field. And that's good for aurora viewers in the north, not so great for aurora viewing in the south. Maybe I'll just leave it there. It is exciting, though, that we get to end. I think we should still end at 9 o'clock Pacific time, which is midnight Eastern. We'll still end at that time. And what a great thing to be able to end with an aurora. Thank you to Manitoba. Thank you to Explore.org and Churchill for keeping the camera going. Even in the season where the skies are bright. This camera runs 24/7. It's on during the day if you wanted to check it out. It's at a research station there in Churchill. But just such a great tool for observing the sky. And I want to, of course, acknowledge the University of Calgary and the Canadian Space Agency for their incredible investments in all these instruments that we're, well, not all of them, but the cameras, the equipment that we're looking at on Themis, plus the Space Weather Canada, which does its forecast, plus the support for Aurora Max in Yellowknife. Thank you to the Canadian Space Agency. Because without this support, we wouldn't have these tools. And enthusiasts benefit significantly from these tools because we can improve our own understanding of what's going on. We don't necessarily have to be in southern Canada at an academic institution to learn about the sky when we can go out almost every single night and see it for ourselves. The challenge that we face in the north is that we don't have a lot of access to the professors. We don't have a lot of access. Not the same kind of access as those who are attending university in the south. So why not try and bridge that gap? And that's kind of what we're doing here. Citizen science is a big part of what Astronomy North is doing right now. And this NowCast is actually linked to citizen science. It's engaging the public in the north and across Canada for one simple reason. Canada is the largest landmass under the auroral oval, period. I'll say that again. Canada has the largest landmass under the auroral oval than any other country, larger than more land than any other country on the planet. That's exciting. That means that more of us have an opportunity to experience, within our own country, experience the northern lights, because they're visible almost every single night in northern Canada. And so if you're ever interested in checking out the north, come in the fall. I argue it's one of the best times of the year, if not the best time of the year, to go up to Yellowknife, to Dawson, to Churchill, northern Alberta, northern Manitoba, northern Saskatchewan. Like, these are great. This is an incredible time. Why? Well, it's going to start to cool off a bit, so the bugs won't be as bad, hopefully, knock on wood. It's a heat wave in the NWT in Alberta right now, so I don't mean right now, but in the fall, because you can get the reflections of the aurora, the northern lights on lakes and rivers. You can enjoy the temperature. It's not minus 20, minus 30. And that the cloud cover is mixed in the fall, but generally speaking, it can be a very rewarding experience to travel to the north in the fall to see the northern lights. So if you haven't already made your plans, I strongly recommend you check out flights to Yellowknife, flights to Whitehorse, flights to Dawson, flights to Churchill. Check them out. They're not as expensive as they used to be. It's a 4-hour flight from most major centers in Canada just to get up to Yellowknife or get up to Whitehorse. Just check it out. Seriously. This is in your own backyard. This is an incredible natural phenomenon. It is Niagara Falls in the sky. But it's also part of learning about the nature, the culture, the wonder of Canada's northern sky, experiencing for yourself. The cameras don't do it justice, ladies and gentlemen. They give us an idea, give us a taste of what's going on, but it's not till you see it for yourself that you really understand how incredible the Northern Lights can be, and that we are very lucky in Canada to be the largest landmass under the auroral oval. We're also one of the only places on the planet where the sky has an impact on the economy, he says as something bright and green comes over the Churchill camera. Check it out, top right-hand corner. Pillars of light starting to appear in Churchill. Do we have evidence that is how aligned with the Themis live feed is that? I think I was about to make a point earlier and then interrupted myself, which is it happens way too much. But here's what I think is happening with Churchill. It's a little bit delayed because of the quality of the camera, like the data that has to flow from Churchill back to the servers at explore.org. I'm just guessing here. I don't actually know if it's flowing to explore.org or if it's in a server somewhere in Manitoba. But anyway, my point being is that the data flow would be significantly larger. And what's the evidence? Look at how sharp the quality is versus the Themis imagers. So the Themis imagers are designed to be scientifically more important than they are to be, dramatic and spectacular and high res. These are imagers from the 90s. Sorry, they're not from the 90s. These are imagers from the early 2000s. So this project launched in 2007, and the imagers then basically, I think they had 256. I think they were 256 resolution, maybe 520. I'm probably going to get corrected by Calgary, but it's low resolution imagery. Why? So we can get the live feed from multiple cameras quickly. And that scientifically is a significant added value. So those cameras, imagine all the cameras are on and they're all providing data and they're all sending data back to Calgary. You want those samples, those data. What's the term? I don't want to say data dump because that's the Donald Trump thing. Packets. That's the word. Packets. Can't believe I made a Donald Trump reference on the NowCast. Okay, so the data packets come back to Calgary. You want them to be as small as possible. And so that's why the size of the images that are coming in are a little bit lower resolution. So I think what's happening is we're seeing real time on Themis cameras, and then there's a delay before we see more intense lights in Churchill. So we could expect, because I've been watching the imagers for on the Themis camera there for a bit, is I think we're going to see some more of those periods of increased activity directly overhead on this camera in Churchill. Keep an eye on it. I think I will keep this running for a little bit longer here. But this is great. We're going to sign off with an aurora on the screen. Sign off will be at 9 o'clock Yukon time. That's midnight Eastern. This is a long goodbye, but thanks to the aurora, not just me. The aurora made me keep going here. It's an exciting time to be a sky watcher. We're trending towards the peak of the solar cycle, which is expected to be in 2025, maybe 2026. We're going to see more and more of these geomagnetic storms. Why? Because of what's going on in the sun. As activity increases on the sun, there's a chance for more Earth-directed coronal mass ejections. And those Earth-directed coronal mass ejections lead to the watches, the warnings that we just had, G1, G2, G3, all the way up to G5 potentially. We don't get G5s very often. They're very rare. But G1s and G2s become more and more common as we trend towards the peak of the solar cycle in 2025. And this is why it's a great thing to launch a new NowCast, to start talking about geomagnetic storms and invite everybody to come and join in the show. Be part of the experience. Send us your photos when you get an aurora over your community. And let's post it on the site. Let's be one big, happy, photographic family. So anyway, I think I am running out of steam. It is important though just to acknowledge. Thank you to all of you for joining this NowCast today, and I want to acknowledge the University of Calgary for their incredible work on Themis, on Aurora Max, and on an array of projects that are helping us all learn more and more about the Sun-Earth relationship, about geospace, about the aurora, and about Canada's northern sky. I also want to thank my board, the incredible folks, volunteers from Astronomy North, who, like myself, have built-in insomniac power and love what we do, and that's why we keep doing it. And definitely want to give a shout out to the Canadian Space Agency for their support over the years, for helping keep Aurora Max awesome, because the social media, the energy that's gone into the social media from the Canadian Space Agency has helped make it a great success. And definitely want a big thank you to the team at the CSA. And without further ado, I should also acknowledge Tamitha. I want to acknowledge Tamitha Skov, the space weather woman. And if you've never heard of Tamitha, I want you to go to her YouTube channel. It's Tamitha, Tamitha, Skov, Skov. Tamitha is a champion for a lot of reasons, but is a true champion of space weather education now. She has her own channel. She has multiple social media feeds. She is dedicating her time now to helping all of us better understand the science. And because of her, I want to just acknowledge her because of her, nowcasts like this can happen. And I learn a lot from her workshops, and so I recommend you check them out. She does mini courses. She's got lots of videos. Whenever there's an Earth-directed coronal mass ejection or an increased solar wind stream as a result of a coronal hole, she will do a video and give you an update. And it can be pretty technical because she is a scientist. She's an actual scientist. She's been studying this a long time and knows her stuff better than most. And but she's not volunteering. She's choosing. Her career path now is to go onto YouTube and give us all knowledge. And that's amazing. And it really is appreciated. So I wanted to give a shout out to Tamitha. And I'm hopeful that maybe we can have her on one of these live events in the future. Because why not? The more science, the better. And the more experts, the better. And so thank you, Tamitha, for all you do. And what else? Who else? Well, I think it boils down to one last thing. Thanking you for joining us again. So it is now 8:53 local time in Whitehorse. Looks like things have quieted down a little bit in Churchill. We'll keep the camera on for a few more minutes. If you want to check it out yourself, you can go to explore.org and just look up Aurora, Northern Lights on explore.org. And then you can also go to YouTube. It's a feed from YouTube. And again, Northern Lights, Churchill, Manitoba, Canada. Very cool. Anyway, ladies and gentlemen, thanks for joining me. Thanks for being part of this second ever Astronomy North Nowcast. I'd love to hear from you, see what your thoughts are. Leave a comment, subscribe. We just launched this YouTube channel, so we're going to need some subscribers. So sign up, subscribe, be part of our new Citizen Science Working Group on Facebook. There's lots going on. Check us out on astronomynorth.com. Send an email to info@astronomynorth.com. All that said and done, we are probably not having the big show tonight, but we could still have some nice auroras above northern Canada. So ladies and gentlemen, get out there if you can. If you live in the north, get out there. If it's clear where you live, I think you may have a nice show in the north. And southern Canada, don't worry, your turn is coming. We're going to do this again soon, and we'll be able to give you guys a heads up as best as we can whenever there's active northern lights in the skies above your community. Thanks for joining Astronomy North. Thanks for joining me. Talk to you again next time. Enjoy the show. We'll be signing off in about 5 minutes, ladies and gentlemen. Have a good night.